Okay, today we are going to talk about reflections. This is the warm-up. If you weren't here for the warm-up, please go ahead and pause and see if you can remember how to write the equation for each line. So you're going to have an equation like y equals something or x equals something, and sometimes you'll have both a y and an x in the equation. Okay, welcome back. Let's see how you did. Well, for this first one, first of all, I might want to think about the fact that if I have a horizontal line, my slope is 0, right? So in y equals mx plus b, m is going to be 0, which means I'm not going to have an x. I'm just going to have y equals something. And if I look at this line, well, I can think about, well, what about this point? Well, y equals -1, right? If x equals 0, y equals -1. What about this point? Hey, y is -1 again. What about this point? Y is -1 again. I'll bet that's my equation. What about this point out here? I don't know what x would be, but I know that y would be -1. So that's my equation, y equals -1. Now this one has an undefined slope. Remember, vertical line's undefined. That means I'm actually not going to have a y in there because my slope is undefined. But I can still write the equation. In this case, I'm focusing on x because it's a vertical line. So let's pick a few points. -3, 0. What about this one? -3, -4. Hey, how about this one? -3, 4. All right, it looks like x is going to always be -3. What about that point up there? That one right up there. Well, I don't know what y is going to be, but I know x is going to be -3. There's my equation, x equals -3. Okay, once again, if you didn't do the warm-up, go ahead and pause and try it now. Okay, my equation for this one, no matter what y is, x is going to be equal to 5. There's my equation, x equals 5. Another horizontal line means I have a 0 slope, y equals 4. Okay, and well, now I have a slope. Well, I could write this as y equals mx plus b, or I could just pick a few points, and I can say, oh, that point's 10, 10, so x is 10, y is 10. That point's 40, 40, x is 40, and y is 40. It seems to me that whatever it is, it's the same. And y does, as a matter of fact, equal x. And I could, as I said, have just written this as y equals mx plus b, in which case, what is my slope? Well, I go over 1, up 1, over 1, up 1. Well, actually, technically, over 10, up 10, over 10, up 10. So my slope is 1, y equals 1x. And where's my y-intercept? At 0. Plus 0, so there's my equation written another way. All right, and for this one, well, I could write it this using slope-intercept form, or again, I can do it a little more instinctually and think, well, that point's 1, -1. That point's -2, 2. Looks like y is the opposite of whatever x is, which is in fact my equation, y equals -x. And if you want to think about it slope-intercept form, I have a slope of -1. I go down 1 over 1, down 1 over 1. And my intercept is 0. So once again, y equals -1, negative slope, times x, plus 0. Same equation. All right, so today we're learning about reflections, or we're learning more about reflections. Let's review the definition of a reflection. It flips a figure across a line called the line of reflection, wherever that line is. And each new point is the same distance from the line as its original point. So however long one point is from that line, its partner point has to be the same distance on the other side of that line. And remember, these figures are going to be congruent. So you're going to have the same size and the same shape. It just is going to be flipped. All right, so let's see. It already gives us our initial figure and the figure after it's transformed, so our image. And let's go ahead and get the coordinates. There's our point G. Go ahead and pause and practice finding the coordinates of the rest of the points. Here we go. There's x, 3, 3. There's f, 4, 1. G prime, or G sub 1, is -2, 2. X sub 1 is -3, 3, and f sub 1 is -4, 1. Okay, let's find the line of reflection. Well, if we go from G to G sub 1, what's halfway between those? Hey, that looks like it's actually this line right there. And that's what it is. And you can do it mathematically too, but really what's happening? It's that far away, so this point's got to be the same distance away, and it is. And it's that way for each point. X is that far away, X sub 1 is the same distance, same distance. So what's the reflection? It is reflected across the y-axis. Easy right now, right? We're going to get more difficult. Okay, now we're going to reflect triangle UXL across the x-axis to create triangle UXL sub 1. First thing to do is draw the line of reflection. What did it say the line of reflection is? Across the x-axis. So there, the x-axis is our line of reflection. All right, well, let's both give the coordinates and draw our coordinates of our image, of our reflected image at the same time. So what's the coordinates of point U? -3, 5, right? We go over 1, 2, -3, up 1, 2, 3, 4, 5, and there's point U. But now if we're going to reflect across this line, then we've got to think about, well, we're going down 5 points to get to the line of reflection. So we've got to go down another 5 points to get to the image point. So there's going to be U sub 1, right? And what's those coordinates? -3, -5, right? Now we're going back 3 and down 5 instead of back 3 and up 5. How about point X? 0, 5. So because we didn't go side to side, we just went up 5. Well, now what do we have to do? We have to go all the way down to the line of reflection and then the same distance there. And mark our point, X sub 1. And what are the coordinates? 0, -5 now. Hey, look at that. All that's changing is our y value. And it's the exact same, it's just the negative of it. All right, point L. -3, 1. Can you predict what L sub 1 is going to be? What happened to each of these? It was just the opposite, right? 5 to -5, 5 to -5. I wonder if this is going to be -1. So I would have a point of -3, -1. Let's see. We go down 1, down another 1. There's our point. And -3, -1. Hey, we were right. All right, there's our reflected image. Okay, so we have to give the coordinates, and then we're going to describe the reflection. But look, this one isn't going across either of the axes. This is going to be a little trick here. We're going to find the line of reflection and then describe the reflection. Okay, well, let's first go ahead and give the coordinates. Coordinate of P is 1, 0. Go ahead and pause and do the rest on your own. Okay, D is 1, 4, E is 4, 3, I is 2, 0. P1, P sub 1 is 5, 0, D sub 1 is 5, 4, E sub 1 is 2, 3, I sub 1 is 4, 0. If you made a mistake, pause and look for it. Okay, now I need to find the line of reflection. Well, let's see. And I know some of you are looking at this already and thinking, I know what it is. Let's do it mathematically for a moment. So what here is changing? P and P sub 1. What changed? Our x value changed, but our y value didn't change. How about D? Our x value changed, and our y value didn't change. And if we think about it, well, that's all, if we look at this, that's all that's happening. Is it's staying at the same location as far as y values go, right? It's just going across some line here. So if we look at our x values, couldn't we say that it has to sit in between, halfway between these 2 points? Well, let's think about it. If it has to be halfway between the x values, can't we just find the average and say 2 plus 4 divided by 2 and find the halfway point, which, yes, is going to be 3? 2 plus 4 divided by 2, and that gives us 3. And as a matter of fact, that's exactly right. X equals 3 is going to be the line of reflection. All along here, x is 3. There's our line. So E to E sub 1, both of those are 1 unit away. D to the line is 2 units away. to D sub 1 is 2 units away. And if we look back here, there's a difference of 4 units. But if we average these numbers out, we would find out that 3 is that line of reflection. All right, so if we describe the reflection, what do we have to say? It was reflected across the x equals 3. The line of x equals 3, or just reflected across x equals 3. All right. Reflect polygon JTME across the line y equals -3. All right, we're not using an axis again, and we're going to create the polygon JTME sub 1. First thing to do is draw the line of reflection. Well, if y has to equal -3, if I'm not comfortable with that, I can just pick some points, right? So there's a point where y equals -3. There's another point where y equals -3. And there's another point. There we go. There's our line. Okay. So let's go ahead and do the coordinates at the same time as we do this. So what's the coordinate, the current location of j? -3, -2, right? I have to go back 3, 1, 2, 3, and down 2, 1, 2. So j sub 1 has to be the same distance from this line as j is. Well, so I go down 1 unit to get to the line, and then 1 unit on the other side of the line. And there's j sub 1. And what's the coordinate of that? -3, -4. How about point T? Where's point T right now? It's at 0, -1. See, I start at the origin, and all I do is go down 1. So now I have to go down to the line. That takes me 2 units. And now on the other side of the line, that's going to be 2 more units. There's my point. There's T sub 1. And what are the coordinates of that? 0, -5. And once again, if I think about from -1 to get to -3, I have to go down 2 units. So then I have to go down 2 more, which takes me down to -5. Okay? You don't need to understand it that way, but I want to give it to you for those of you who are ready to understand it that way. All right, point M, 3, -2. So I have to go down 1 unit to get to the line, 1 more unit to get to the other side. There gives me n sub 1. So 3, -4. Point E is at -1, -5. So I have to go up 2 to get to the line. Means I need to go 2 more to the other side. And there's E sub 1. And its coordinates are -1, -1. All right. There's my shape. There's my reflected shape, my image. Okay, so there's 2 of the most difficult problems that I picked from the homework to go together. So this one is asking for a reflection across y equals x. Oh, that's not going to be a horizontal or a vertical line, is it? From our warm-up, we remembered that y equals x is a diagonal line, like this. Now, if you didn't remember that, well, you could just go ahead and make a table. Let's see, if x is 1, what is y going to be? If y equals x, y is going to be 1. Plot that point. If x is -3, I'm just picking random numbers. What is y going to be? -3. Plot that point. How about if x is 0? What's y going to be? 0. Plot that point. Now I have 3 points. They lie in a straight line, and I can draw that line. Okay. Now I need to reflect across y equals x. So I'm going to have to think about straight lines to that line. I'm going to have to think about perpendicular lines. So if I've got to go 1 that way, it's not really 1 unit, but a diagonal unit, then I'm going to go another 1 this way. Same thing with h. I've got to go that far. So that's kind of thinking about 1, 2.5 of these diagonal units. So I'm going to go 1, 2.5 to this side. Cute. And you could also do this if you want. You could go across and then down each one. I could go across 1, 2, 3 units, and then down 1, 2, 3 units. Let's see if that works for P. If I go across 1, I need to go down 1. There's 1. Now that only works when we have y equals x. If you get to more complicated lines, it's not going to work exactly that way, but it'll work that way for now. I can draw my figure, and there I'm done. Woohoo! 1 less problem from your homework. Okay, One other problem to do together, number 8. Okay, so we have to think. The line needs to be so that the distance from u to the line is the same distance as u sub 1. Well, that means that if I go this way, there should be some point halfway in between where the distance is the same. Well, what is halfway between? It's right there. So let's mark that point. How about D? What point is halfway between D and D sub 1? It's actually the same point, right? Because they're on top of each other, so halfway between them is the same place. Let's mark that point. Let's do one more. How about halfway between T and T sub 1? That's going to be right about there, isn't it? And so that line is going to look like that, right? And what's the equation for that line, if we think from our warm-up? And you can also pick some points and see if you can find the pattern. Y equals negative x. And yes, you could have also used slope-intercept form to figure out that equation. But so this one is reflected across, so please say that, reflected across y equals negative x. All right, that was a long video, but we got together our warm-up, our lesson, and 2 of your homework problems. So see you in class.